Yeah, you guys know who that is.
Hey, I pointed out.
Okay, so when you're done today, Bailey, try to listen up. You listen from the start, you'll understand. After this, you'll know what voltage means, and you'll be able to solve a new formula, V equals E over Q, or else I'm going to send, what's his name? Electroactive. Okay.
That's not how we're scaling and for.
We're going to talk a little bit about current to begin with, because you need to make sure you understand this before we move on. So let's talk about current. Oh, that's... What's a circuit? Okay, you guys have to fill some stuff in here, right? What's a circuit? We haven't talked a lot about this.
Connected to the terminal
Yeah.
of a source, making a
Complete path. Complete path, right? So when we say, like here I have a little light bulb, right? What do I need to make this a circuit?
Power source.
Yeah, which would be like a battery, right? So if I put this D battery back in here, and I connect the wires, which are all twisted here. If I connect it like this, what's going to happen? Should light up, right?
Theoretically.
There we go. You can see? See the light? So I completed the circuit, right? Okay. What are the terminals? What does that mean? Like, what are the terminals on the 9 volts?
The two
Little thing.
Two little metal thingies on the top, right? That Nolan's gonna like. Wait.
I've done it at home.
I'm sure you have. So, what is an electric current? A flow of charge. Now, Nolan, when we say a flow of charge, are we talking about positive charge or negative charge? You need to know this. No, it doesn't.
Negative.
Both.
It is a flow of electrons which are negative. Do the protons move?
No.
They do not. Do you understand that you're supposed to fill this stuff in? So I'm confused why you're not doing it. Do you have a pencil? Okay, well then you got everything you need. So, electric current is simply a flow of charge, a flow of electrons. I equals Q over T. We solved problems with that last time. Right? The higher the current in a wire, the faster the charge you're passing through. It's kind of like cranking up the garden hose. The water's going through a lot faster. Okay? If you got a pressure washer at home, would that be the same as more current or less current? More current, because the water comes out blasted, right? Fast. So it's how fast the charges are passing through. What's the symbol for current? I. We were just reviewing here. Symbol for current is I. We don't know why. Units for current? Amps or amperes.
Meter.
Current or wire. Symbol? Units.
Oh my god. Why don't you?
Is there anyone else that's not sure where to write this down? Because I don't want you to ask me later. You missed this part too, Kate. That's why it's important to pay attention. If you're having little side conversations, it doesn't work, you guys. It really, really doesn't. It's hard to learn something new when you're talking about something else. You can't multitask.
He literally talked about sacrifices while you're having sacrifices.
What? Hey, you capture yourself like you can say conversation.
Conversation. Well, can you go back down? I was
You were
having a conversation.
you were getting it. You were feeling bad that you were left out of the side conversation.
You so.
There's no sacrifice.
Okay. Don't start a new side conversation. Pretend you're at the dentist's office and you're waiting and you don't know anyone.
I just start laughing. My brother makes it interesting.
Good, Kaylee?
Yeah.
Okay, now you need the next page, Kaylee. Symbol is I. Units are amperes. Okay, and this is the amount of current that flows past a point in a second, or per second, right? Time must be in seconds. I think that's all the review we've got, isn't it? Oh, it's not. There's one more thing. Now, I haven't talked to you about this. Do you have any idea what you measure current with? You're going to do this when we do the online lab. Well, what's it called, though, the device? Do you know? Don't know? It's called an ammeter, or if it's really, really, really tiny current, we measure it with a galvanometer. And you're supposed to know those terms. Okay? Do I have one back there?
Why is it called an ammeter?
I don't know why it's called an ammeter and not an amp meter. I don't know. Yeah, I don't see one back there.
Hey, where is it?
Right here where it says measured with.
Oh, there you go.
It's like you guys have never done these kind of things before.
Well, I thought we were long past.
Oh no, no. What's the next thing you're gonna see on the slide on the screen? Voltage. And then it's gonna say symbol, V, units, volts, right? Used to describe the amount of, you're gonna have to fill that in, right? That's an ammeter. It'll say amps right on it. I'm not too concerned about that.
Why is it called an amp
I don't know.
when there's another thing called an amp? The amp.
I don't know, man. I don't know. Can't help you. There's a galvanometer. It's got a G on it. It's for measuring really small currents. Okay, let's talk about voltage. So what do you think voltage means? We've talked a little bit about it. Someone sort of said, like, the amount of charge or strength, that kind of thing. You're on the right track. The symbol for voltage is easy. It's a capital V. You already have that. The units for voltage, pretty easy. Volts. So big V stands for voltage. The units are volts, which is a little v. It's used to describe the amount of potential difference in energy. That is a confusing concept. Potential difference in energy. And I will explain it the best way I can, and there's a good chance that 90% of you won't get it, and that's okay. To be perfectly honest, I don't think I understand it truly well enough to explain. Okay? How much energy does the tennis ball have?
They're not.
None? You guys know about potential energy? Why is there potential energy to that?
Because gravity.
Gravity, right? If I let it go, the potential energy is going to be converted to kinetic energy, right? And if I hold it farther down, it's got less potential energy. If I hold it up high, lots of potential energy. So this is like a 9-volt battery, lots of potential energy. This is like a 1.5 volt battery, not as much. Kind of like that. It's got to do with how far away the electrons are from the photons and all this sort of confusing mumbo jumbo. But that's the basic idea. Sort of, yeah. Sort of. Okay? Easy stuff. You measure volts with a voltmeter. If you've ever used a multimeter, electronics, some of you guys take electronics at the start of the year.
Yeah.
Okay, so you might have had a voltmeter out. Yeah. So do you have to write that down? Measure it? No, you don't. You're lucky.
Yeah.
There's a voltmeter. You should have flipped the page by now. Yes.
There's me in the bottom.
Okay. Thank you to Mr. Dick for these wonderful illustrations. Yeah. No, he didn't draw me. Hold on there. I put them together. So, low current, low voltage. So there's a picture of me, junior high years, kind of skinny, right? Low, and there's only 3 of me. So I got low current, low voltage. Now what do you guys have? You have the picture, right? And then what? Okay, so low current, low voltage. So each electron has a little energy in red, little energy, and there's only a few of them, right? So that is low current, only a few of them. What's the total? It says equals and then there's a big blank line. What's the total energy? Low total energy. Skinny guys, and there's only 3 of them. Low total energy. That goes on that big, thick black line. Okay? Low total energy goes on that thick black line. Now the next picture shows what?
There's a whole lot of them.
A whole lot of skinny guys. So what's it going to be?
Energy. But they're.
High current, because there's lots of them, but still low voltage. You got a bunch of skinny guys. Have you got more energy than before? You do, because you've got more skinny guys. Each electron still has little energy, but there's lots of them, lots of current, lots of water coming out your garden hose, your tap, whatever. Yeah. Each electron has little energy, but there's a lot of them. Do we have more energy than before? We do. Moderate, medium, in between total energy. Just a warning, on the test, there'll be one of those 4 pictures, and I will get you to ask me, what does this describe? So you might want to highlight or put a star beside this page. I guarantee you, you're going to see those pictures again. Exactly the same ones. Moderate total energy. Each one has little, but there's lots of them. Does that make sense? Calista, am I speaking English? Yeah, makes sense? Yeah? Okay. Now, the next picture, here's me, university days. Whatever, right?
What happened?
Yeah, what?
What happened?
Where did it all go?
Lost my hair. Low current, high voltage. Why low current? There's only 3 of them. High voltage, big and strong, Schwarzenegger style. The Rock. Look at that, it's like The Rock, eh? There's only 3 rocks. Low current, high voltage. What's the total energy going to be like?
Moderate.
Still moderate. Each electron has a lot of energy, but there's only a few of them. We're still in the moderate total energy. How do we get high energy? You need a 9-volt battery. You need a lot of current with a 9-volt battery. Then you get lots of energy. Anyone got any ideas why you need a 9-volt battery and a smoke detector? Because really, most of the time, it just does what? Just sits there.
So it makes lots of noise.
I think it's supposed to make lots of noise. When it needs to, the power's there.
So the double batteries can
It's kind of like having that big, strong bouncer at the door. Most of the time, you just stand there doing nothing, but when you need them, like the enforcer on the hockey team, right? So, high current, high voltage, what does it look like? Look at all these guys. High current, high voltage, lots of energy, lots of them. This is the group you want when you're moving your house from one place to another. Yeah. Bunch of bodybuilders moving your couches? Oh, the same guy, yeah. Clones. These are the guys you want when you're sandbagging.
Quintuplets,
Yeah.
identical quintuplets.
8 Logan Packers all in a row. Making fun of me, tossing 30-pound sandbags at me, knocking me over. Yes, I went sandbagging, and him and Logan and Brent Posiak were tossing them around like they were bean bags, and I could barely pick one up because they didn't look like this anymore. High total energy, right? Again, put a star on that page, circle it, do something. Are you going to see that page again? Yes. You're going to see part of that page again. Okay. This is the idea. Do you guys have this? You probably don't need to write this down, right? Yeah. So this is that idea about gravity. When you raise something in the Earth's gravitational field, it gains potential energy. It will start to move if dropped. Same idea in voltage. You have to separate charges, separate the negative and positive. This creates potential energy that is released when the circuit is complete. So really, inside a battery like this, you've got electrons on one end and protons on the other end, and they are separated a long ways, so to speak. Here, they're not separated so far, not as much voltage. It's kind of hard to understand. I'm still not 100% clear on it myself. Okay, here's the formula. V equals E over Q. I'm not going to describe it, I'm just going to say, boom, here's the formula. When you get to me in grade 12 physics, a lot of the formulas I'm going to derive, I'm going to show you where they come from. It's probably the most exciting thing we do. I say that with complete sarcasm.
I like this thing.
But we do them because it's something that you need to sort of experience. But for today, I'm just going to say the formula is V equals E divided by Q. V is voltage, measured in volts. E is energy, it's measured in joules. Joules of energy. Does anyone have any food or snack? I see a Snapple. Can I borrow your Snapple can? Is it empty? It's not empty? Let me see if there's one here in the recycle bag. Oh, here's chocolate milk. Though. Here's Snapple. Okay. I have 3 drinks here from my recycling. This one says 90 calories. What does that mean, 90 calories?
There's 9 calories.
Well, what's a calorie? What's a calorie? Energy, right? And where does that energy go? Into your body, and then you can use it for doing whatever, right? Chocolate milk, 170 calories of energy. Snapple, 160 calories of energy. And this is the same energy as this. Okay? Most food is measured in calories, but there's one food, I've only ever seen one, where they show the energy in joules. It's not water. It's on your breakfast table.
Cereal.
It has to be labeled. It's a certain type of cereal.
Special K.
No. Vector cereal. If you've got a box of Vector at home, it will show the energy in joules. I don't know why, but it's there. Okay? Same idea here. Energy. Okay? Q is charge measured in coulombs. Here are the other versions of the formula. Do you have them? Do you have them there? I lost mine. Here are the other versions. Oh, there's the formula, right? Okay, so where it says formula, I want you to write the first one, and then other versions you're going to write underneath, right? Now, at one point, I thought it would be a good idea to fill this table out right here. And then I realized, you know what? Kids need a sheet with all the formulas on. So put a big X on this one right here. And where are you going to put them now? On the yellow sheet, because that's the one you want for the test. Right? So, let me go back to my yellow sheet page. What's the first quantity that I want to put down here, do you think? Go ahead. Go real quick, because we're going to do some sample questions anyway. Are we all good? Is your brain swimming?
No.
You still have enough energy to complete this?
My brain has so much drag. I'm using
Okay. Remember, I don't have it up here, but you guys have it. Remember the rules for solving are there. Let's have a look at example number 1. Let's have a look here. Example number 1. You have it written down there, right? Excellent. Okay, so if a battery uses 45 joules, the battery uses 45 joules of energy with a charge of 15 coulombs. What is the electric potential? Now, there's a word you haven't seen yet. Scientists like to have many words for the same thing. They're a bunch of jerks. What do I mean by electric potential? Gravitational potential, electric potential, but electric potential has a special word that we call voltage. Electric potential just means voltage. Okay? So, V equals E over Q, we're going to write the formula. Am I making you do that? Yes. I will shame you into doing it. I'm not ashamed to say that. You have to do it. It's a good skill to learn. If you're going to take physics or chemistry, you got to start to learn how to write formulas down. V equals E over Q. What is the E? 45 joules of energy. How do I know that E is 45? It says of energy. 45 joules, I can look at my sheet and I can tell that's energy. With a charge of, so that's my Q, 15 coulombs is charged, so it's 45 divided by 15, 3 volts. If you put 2, if you have a remote control with 2 AA batteries in it, you've got 3 volts. A lot of things take 3 volts. A lot of things. Is that easy to do?
Yes.
More or less. What's the next? Do you think you can do the next one on your own?
Yeah.
You know what? You try it because there's lots of space there. If you make a mistake, you can fix it. I'm going to give you about 90 seconds while I mark my attendance, and then I'm going to show you the answer. Yeah, I'm going to do it right away. Go ahead and try it. If you get it wrong, that's fine. It really is. Try it. I'm going to mark. Example number 2. I'm showing you how to do it. What do you think's coming next? I'm going to give you a sheet where you're going to try these on your own. Okay? How many joules of energy? How many joules of energy are released from a 9-volt battery that has a charge of 25 coulombs? Okay? What am I solving for? How many joules of energy? I'm solving for E. You go and you find the formula, Bailey. I'm showing you how to do it right now. Santana, are you watching? Santana, I need you to watch. You're not watching. You got your head down. Watching is eyes up. I'll just wait until you get your eyes up there. Okay, thank you. So I'm solving for E. It's Q times V. Which one is Q? 9-volt battery. That's my V charge of 25 coulombs. So you would write V equals 9. Q equals 25. Solve for E. 25 times 9, 225 joules. Make sure you've got units.